Today we're going to talk about solutions to linear equations. We're going to start by talking about the overall goal, which is to isolate the variable. We'll start with a regular multi-step algebraic equation and then work into some more complicated ones. So for example, 3x plus 4 equals 13. The goal is to get this x all by itself. So what we want to do is get rid of the 3 and the 4. You work the furthest away from x until you're right up next to x, and then x is by itself. So to get rid of this 4, we would have to subtract 4. But whatever you do to one side of the equation, you have to do to the other. So we'll subtract 4 from both sides. These 4's are going to cancel, and we're left with 3x is equal to 9. Divide both sides by 3, and we get x is equal to 3. Now the nice thing about algebraic equations is that a lot of times you can take that answer, plug it back into the original equation, and make sure you get what we started with, or you get a true statement. So let's plug that answer, x equals 3, back into the original equation. We get 3 times 3 plus 4, and if we did our algebra correctly, that should be equal to 13. Well, 3 times 3 is 9, plus 4 gives us 13 equals 13. That is a true statement, so that means our answer is correct. Now let's spice things up a little bit and put variables on both sides. 5x minus 12 equals 3x plus 6. What you want to do is get the variables on one side. So you can either bring the 3x to the 5x, or you can bring the 5x to the 3x. I'm going to bring the 3x to the 5x. So I'm going to subtract 3x from both sides, because 3x minus 3x, these are going to cancel. And then the 5x minus 3x, we're left with 2x minus 12 is equal to 6. Now it's just a regular multi-step equation, just like the one before. Add 12 to both sides. 2x equals 18. Divide both sides by 2. And we're left with x equals 9. Now you can take that 9, plug it back into the original equation up here, and you'll see you get a true statement. Now the next example on your paper involves distributing, so go ahead and give that a try, and we'll go over that in class. Now let's talk about the linear equations that have fractions, our favorites. For example, negative 2/3 x equals 10. Well, I'm going to show you a way that you actually don't really have to deal that much with fractions. We'll rewrite it. So what we have is negative 2/3 times x, which that's really x over 1. Multiply the numerators, multiply the denominators, and you have just one big fraction, negative 2x over 3 equals 10. Now we'll solve this like we did the other ones, work the furthest away from x, and get x by itself. So we'll get rid of this 3 first. This is negative 2x divided by 3, so to get rid of that, we'll multiply both sides by 3. These 3's are going to cancel, and we're left with negative 2x is equal to 30. Divide both sides by negative 2, we get x equals negative 15. Let's try another one a little more in depth with fractions. For example, 2x minus 4 all over 4 plus 6 equals x plus 5 all over 3. So what we can do is we can actually get rid of the fractions by multiplying the entire equation, the left side and the right side, by the biggest denominator. And repeat that method until all your denominators are gone. So the largest denominator we have is 4. So I'm going to take the entire left-hand side and multiply it by 4, and the entire right-hand side and multiply it by 4. Distributing is important here. There are two terms here, this first term and this second term. So you need to make sure to distribute the 4 to both. Here, when you're multiplying a fraction by a number, you just have to multiply that number up at the numerator and make sure you distribute that 4. These 4's are going to cancel, and we're left with 2x minus 4, and then the 4 times 6 gives us this 24. And then we distribute the 4, and we have 4x plus 20 over 3. Combine like terms. 2x plus 20 equals 4x plus 20 over 3. Now let's repeat that exact same process, getting rid of this big denominator 3. Multiply the entire left-hand side by 3 and the entire right-hand side by 3. Distributing is important. Distribute the 3 here, and then these 3's are going to cancel. So we're left with 6x plus 60 equals 4x plus 20. Now it's a regular multi-step algebraic equation with variables on both sides. You can bring the 6x to the 4x, or the 4x to the 6x. I'll subtract 4x from both sides. 6x take away 4x. Here's my 2x, plus 60 equals 20. Now it's just a regular multi-step equation. Subtract 60 from both sides. 2x equals negative 40. Divide both sides by 2, and we get x is equal to negative 20. Whenever you're in doubt about your answer, you can always plug it back into the original equation and make sure you get a true statement. Now we're going to talk about solving equations with multiple variables. So this means you have like an x and a y or any other variables in it. Our first example, we're going to solve 5x plus 2y equals 12 for y. Now don't forget about how to do this because we're going to revisit this when we talk more about linear equations, y equals mx plus b, line, slope, and all that other good stuff that's coming up in the future. So we'll take this 5x plus 2y equals 12 and we're going to isolate this y. We're going to do it the same way we did in the other examples. Work the furthest away from y until you get the closest to y and then you have y by itself. Now we're going to get rid of this 5x the same way we would as if it was a 5. Subtract it. But notice 12 and 5x are not like terms, so we can't combine them, we keep them separate. So we have 2y is equal to negative 5x plus 12. Now to get y by itself, we're going to divide both sides by 2. But you're dividing this entire side by 2, which means you need to divide each of the pieces by 2. So we're going to divide that negative 5x by 2 and that 12 by 2 and reduce. Y equals negative 5 halves x plus 6. Let's take a look at one more. Let's solve v equals LWH for w. Now the operation here is L times W times H. You've probably seen this before, volume equals length times width times height. So we're going to start with that. We want to get W by itself. Well, what's the operation between L and W? Multiplication. Between W and H? Multiplication. What undoes multiplying? Dividing. So we can actually just divide both sides by L and H at the same time. The L's are going to cancel, the H's are going to cancel, and we have V over LH is equal to W. Or if you wanted to write it the other way, W equals V over LH. Now there's a few other problems on your sheet that you're looking at now that I want you to try, if you feel like it, if you want to, if you feel comfortable enough, and we will go over these in class. See you then.